Today we are going to introduce about Earth's weather and atmosphere. The atmosphere is a layer of gases that surrounds Earth, and as you can tell from this view from space, it's not necessarily a clear, exact boundary. It's not like this invisible bubble that stays and remains. Instead, it's kind of a continuum of gases. However, one thing holds all the gases around Earth, and that is gravity. If anything escapes Earth's gravity, then it's able to float off into space. But for the most part, our Earth's gases in our atmosphere stay there because of Earth's gravity. Our atmosphere plays a lot of different roles for us. Most notably is our weather and climate. And when we talk about weather and climate, we have to talk about how Earth is going to heat differently based on land versus water, based on equator versus poles, based on what the Earth is covered with, whether it's covered with rock or soil or trees or desert. And so all of that plays a role because essentially what weather is the movement of heat and movement of moisture around Earth. The other thing that we have to consider is that Earth is not a perfectly straight axis tilt. Instead, it's tilted, and that's what also helps give seasons, and it also keeps our winds from being straight line. In other words, we could potentially have hurricanes all the time if we had a planet with no axis. So when we look at weather, and we look at a weather map, whether it's on TV or the Weather Channel or weather.com, we get a lot of different looks. Some of them will have a H and an L. A lot of students think, oh, that's high temperature and low temperature. Instead, one of the biggest factors is high pressure versus low pressure. Air is in a constant chase with each other. It always wants to try to balance out. So high pressure is always chasing after low, low is always chasing after high. And usually when we talk about high pressure systems, what that means is that literally those air molecules are tighter packed and they're going to be able to kind of bully and scurry away the low pressure. Low pressure means that there are fewer air molecules. And so what that allows is it actually allows water molecules to get in between the air molecules. And when you look at this weather map, notice by the L's, that's where we have clouds, that's where we have precipitation. Even on this area right here, sorry about that, we're seeing that there's clouds or there's moisture along that low front. And that's because there's water that's able to get through the air. When we talk about air, it changes based on high pressure, low pressure, of course, but other factors that make it either high pressure or low pressure would be its elevation. So you've probably driven on a plane or rode on a jet before. And so as you go up in elevation, it feels cooler. The reason for that is that there's literally less air that's hitting our skin, and we perceive that as it being cool. Even though those air molecules might be scurrying around and moving really, really fast, we don't feel that as heat because there's less of them hitting our body and causing the friction that we feel as heat. We can also talk about this in terms of cold air versus hot air. So we've talked about this plenty that when things are cold, they tend to huddle together. Air is more dense. And then when they're warm, they're able to spread out. You will sometimes experience this, like if you go to the basement in the summer, it's usually cooler. Where in the summer, if you go to the top floor of your house, it's usually warmer. Hot air rises because it's less dense. Cold air sinks because it is more dense. And so not only does that happen in our house, but it also happens in our atmosphere. So it kind of creates this same idea that we talked about with the mantle, this convection of air. We see this a lot in land versus water heating as well. If you've ever gone, up north or gone to the ocean and you go out at night, have you ever noticed that the lake or ocean is very clear? It's very flat. There's very few waves. That's because at night, land and water are essentially heated the same. But during the day, land, because it's a solid, has molecules that are closer together. So it causes land to heat up faster, where water doesn't heat up as much. We've talked about this before. Like it takes us a while for us to boil water for our mac and cheese. And so that not only heats up that water or that land, but also the air directly above it. So now you have different heating of air, different density of air, and all of a sudden you start the chase. And so you can get what's called land versus water wind that occurs. We mentioned this already, but when we talk about the equator versus the poles, I think it's pretty obvious. We know that if you're near the equator, you're going to receive more of those rays, more heat. If you're towards the poles, certain times of year, you're going to receive less heat. And so that change of heat is going to also create different temperatures of air. There again, air is going to chase after itself. Kind of made mention of this already, but there's what's called day versus night heating. So just because you have land, you have water, they heat differently. You can create things like updrafts and downdrafts. You can get waves from the ocean, movement of water from the ocean. And so that's a big deal when it comes to global scale. There's what's called local weather. Like if we're Chicago and we're the Windy City, this happens all the time because of Lake Michigan and then the land that is Chicago plus all the skyscrapers and solids that are found there. And then also worldwide with literal land versus ocean. Another huge factor that comes into weather is humidity. So he said that essentially weather is wind and water chasing after each other. Well, humidity can exist in different portions depending on what the earth is covered with. So if we're in an ocean scenario like what we're seeing on the left, there's obviously a lot of water that can be added to the atmosphere. And so usually air right above the ocean is very humid. If we're above the desert, notice that there's only like 3 molecules in that little capture. If we're on a rocky mountain, also not much water. If we're in a grassland, you're seeing more. If you're in a forest area, if you've ever seen pictures of like a rainforest, it almost creates its own clouds. So humidity has a big, big impact on the weather, both locally and globally. And so when you put that all together with different heating of equator versus poles, land versus water, different kinds of lands, local water versus global water, that creates our weather. And so that's kind of the overall introduction to what causes weather on a global scale. Another one that impacts weather is latitude. So we kind of made mention that if you're near the equator, you receive more and more direct rays of sun, thus making you warmer, right? If you're near the poles, you receive direct rays in the summer, but not in your winter. And I think most of us know this, but winter in North America is actually summer in Australia, mate. But winter in Australia is actually summer for North America and Asia because of that tilt of Earth. And so if we look at an example of how latitude plays a role, but then also how close land is to the ocean, we're going to take a look at an example of Trondheim, Norway, and Frobisher Bay, Canada. So here's kind of a crazy thing. Frobisher Bay on the left, Frobisher Bay is on the right, Trondheim is on the left. These are taken at the exact same months as each other. But notice how Trondheim, which is at the same latitude, and Frobisher are receiving way different weather. Well, here's the reason why. If we look at this from a Google map, here's Frobisher Bay, Canada, with the red dot. That is next to an ocean, but that is receiving cold currents from the ocean. Trondheim, Norway, over here, actually receives warm ocean currents. And so the ocean has a huge, huge impact on the weather of an area. Another example for us, Seattle. You guys know that it's super rainy in Seattle, but rarely gets snow. We are actually at a more northern latitude than Seattle, and we get snow. The reason for that is in Seattle, Washington, they actually get a warm water current, that goes right by them. So let's take a look at what we call global ocean currents. So here's Frobisher Bay that we talked about, and notice how it's getting cold currents, not only from the Labrador, but also from the East Greenland current. We just talked about Seattle. It actually gets warm current, so it's receiving warmer water. That's why it rains. We are in the middle of a continent. We don't have the benefit of that warm current, and so that's why we get snow. If we look at the Norway, again, it's getting warm currents, and so of course it snows in Norway because it's really north, but right along the coast, it doesn't get nearly as much snow because of that warm current that it's getting. If anyone's ever seen the movie Finding Nemo, there's a very famous part where the little turtle, I forget his name, it's like Cruz or something like that. That's not the name. But they ride the EAC, which is the Eastern Australia Current. So right here, it's literally the movement of water. It's hot water that's moving. And so just like how weather is moving in terms of different air, different water is also moving in the ocean. Now, the reason why the ocean is different, of course, is because same thing, different heating. The equator is going to have warmer water than the pole, so there you get different heating. You can also add into it the salinity, so how salty the areas are. More salt equals more density, and so more dense is going to sink, less dense is going to rise. And so those are all things that not only impact weather, but that ocean and those currents are going to impact the air above it. And so that's also an impact of what happens with our weather. All right, so that's a brief recap of how global weather happens. Different heating of land versus water, different heating of equator versus poles, whether you are right next to the ocean, whether you're inland, and then also the ocean itself, how that gets different currents. So all of that impacts the movement of weather, which again is the movement of air and water. Thanks, everybody.